Hi, I'm Aaron Porter of Professional Boat Builder magazine. Welcome to Mets Connect Tech Talk Green and Blue, where we'll be looking at a few technological and materials-based initiatives that promise to improve sustainability of boat propulsion and construction. We know that boat building, like every other industrial and manufacturing endeavor, must adopt cleaner technologies and practices in the future. But where to start and which changes offer the greatest benefits for the investment? Let's get underway by looking at some emerging technologies that offer increased efficiencies with vessel propulsion, especially for large vessels. Donald, you've been leading the research and development team developing a smart wind assist propulsion system. Tell us how much these modern wings or sails can improve efficiency and what they'll entail for boat builders and designers looking to use them.
Thanks, Aaron, for the questions. And yeah, so at SMAR Azure, we've been developing the SWAP, so the Smart Wind Assisted Propulsion System, for the last 5 or 6 years. And here we've created a system that can save around between 15 and 20% of fuel on large vessels, and also reduce greenhouse gas emissions. But with actually a very good return on investment, and saving significant amounts of money with the reduction in fuel. Our system is a solid rigid wing with fully automated control, and designed around a retrofit so that it's easily adapted and easily tailored to specific vessels. Our device operates over a large wind range and provides some of the most efficient propulsion you can to a vessel making use of the wind to do so. So here's a little overview of SWAP, and showing a kind of a suitable rendering of it on a typical large scale tanker, which would be some of our target vessels. Our project so far, we've been carrying out wind tunnel testing, and also in alongside this, we've created our own custom VPP system to predict the performance of ships with wind assisted propulsion added on. And with that, we're able to simulate journeys across the world. So following typical vessel journeys over oceans, and looking at what the return for specific vessels on specific journeys would be, and how much performance we can actually achieve from there. We're also able to feed different vessels. So we have different hydrodynamic models and different aerodynamic models for the propulsion systems, and can look at different configurations, different setups for a specific vessel or for across different vessels, but also compare different technologies. So not only our own SWAP system, but we can look at other competitive technologies. This is trying to address some of the challenges of the shipping industry and the global shipping industry. So looking at trying to get better competitive charter rates, and with tightening emission regulations, these things are becoming more and more important and necessary for the shipping industry to meet the global challenges of reducing carbon emissions worldwide, which is why we think this is such a key and fundamental aspect of the shipping industry has to take seriously and address properly over the next, well, I guess it should be doing already, but needs to do more in the next 5 years as we move forward. Our plans going forward and what we're doing, well, at the moment we're looking at large scale validation. So we're actually building a kind of almost full scale model that will be tested in a wind tunnel. And we then aim to move forward to a pilot study where we will be putting a device on a suitable ship, probably some of the smaller cargo vessel, and then looking at commercial installation as we move forward into the future. I think that's all from me for now. So thank you very much.
Aaron, your mic is off.
Sorry, thank you so much. Donald, I wanted to get some input from you on the size of the appendages that you're designing. Obviously, they're sort of designed to scale to the vessel that they'll go on. but talk to me a little bit about the construction of them, and then you talked about being able to retrofit them on the vessels. I'm curious about from a builder's perspective, what's necessary, at least conceptually, in order to structurally attach them, bend them to an existing vessel.
Sure. Thanks, Aaron, for the questions. So the devices are around in the region of 4 meters on the deck. So 4-meter square space on the deck that's required for the base. And then we actually have a very modular system. So we can tailor the height of a device to specific installations, but we expect them to be between 28 and 32, 36 meters high. In terms of the structural requirements, it would be a case of trying to tie into the main structural members already present and reinforcing the deck around the area of that install, where we just be augmenting the steelwork that's already there, providing additional members to carry the loads, and transferring the load through that. In terms of the device itself, we see as trying to keep the very, very simple and very standard technique. So a steel lattice frame providing most of the structural part of it, and then a composite, so fiberglass shells to form the outside as a solid surface on the wing, and then that would protect all the equipment that's inside, to get the aerodynamics we have.
And in terms of trim, would that be an automated networked process and program there?
Correct. Yes. So we would see that the device would be fully automated. There would be no crew interaction at all. It would come on and off and trim itself as required through a computer control system. And in fact, the control system we've already created and used the software for that as part of our simulation process, so we can actually adjust it and tweak and understand the controller through simulating its behavior. Yeah. And
so in that regard, going directly to windward, I presume that the wings would just feather and present the least resistance as possible.
Correctly, yeah, correct. Or even in port, if you're sitting in port and the wind's coming in from a particular direction, they can feather themselves directly into the wind, because obviously as a wing it only operates you have to have some angle of attack. Right. But actually that's one of the biggest benefits of our system is that the very small angles of wind that we need, or the small apparent wind angle we need for the system to operate efficiently. So down to around 12 degrees from the center line of the ship, and we can actually generate positive thrust for the vessel.
Interesting. And what size, in terms of, obviously we're still dealing with conceptually how it operates, what sizes do you see on the bottom end, in terms of where it can be applicable and useful?
I mean, in theory, it could come down to small sort of 100-meter or so 80-meter type vessels. But it could be, in theory, used on something smaller, but it's certainly very much towards the larger end. So looking at, certainly 100-meter plus would be our target market. So the 60 to 80,000 deadweight ton commercial vessels.
And the construction of the wings, is this something? I mean, I guess what comes immediately to mind is contractors who are doing wind blades already. Is that a likely source for these, or are you looking at workforce maybe in more traditional marine construction sector?
I think we're probably more marine construction sector rather than as you say, the wind turbine blade industry. It is very, very, very trying to stick very much to what's there. Particularly with this, the steel construction, for example, is there many steel fabricators in the marine industry already. Not necessarily, I guess, in the leisure industry, but again, the composite parts, and because of the modular system, we make it very easy to build these and move them around in components and do a final assembly even right beside the ship as it's going on, rather than having to move very large devices around to install them.
I guess we've all learned that the hard way with wind blades. Giovanni and Nico, do you have especially, well, and Friederich too, but any other questions from panel members for Donald about the project?
Yeah, well, thank you, Donald, for the presentation. I think I have a question. How do you think your system differs to other, for example, wing sail systems that are now appearing on the market with assisted propulsion?
Yeah, sure. Thank you, Giovanni. Yeah, so compared to other solutions, we actually provide much higher lift coefficients, so much higher thrust to the vessel than any of the other solutions out there. Particularly, solid static wings. Our system is an active wing, more in line with the Flettner rotor than a wing sail in terms of performance, but actually I kind of a step forward again from a Flettner rotor. So anything up to 40 or 50% more performance than a Flettner rotor.
All right, thank you, Donald.
Thank you.
Great. Any other questions? Donald, thank you so much. This was a great kickoff, and I think we make a very easy segue right now to Giovanni and Nico. You two specialize in consulting with ship owners to understand the potential various modern wind-assisted propulsion options. You have a sense of the different benefits of multiple technologies. Help us to understand the vessel types and use profiles best suited to wing sails, Flettner rotors, kites, or the other technologies that you guys factor in.
Yeah, well, thank you, Aaron, for the question. I can share maybe one slide, so I can give you a brief description of all the models that are currently, well, not all, but say the most typical models that are currently in the market, and then we can discuss each of it.
Great. Yeah, we've got you. That's good.
All right. So yeah, as you mentioned, so there are several different wind assist devices that are currently in the market. They're all very different, and some of them could be more suitable to be carried over to the yachting industry. So of course, they're all made for the shipping industry at the moment, but we can think that some of them can be maybe resized and rethink a little to be applied to large yachts. At the top left, you see the kites. So there is now currently an Airbus spin-off in France called Airseas, and they're aiming to install a 1,000 square meter kite on a large ro-ro ship. At the center, you see a ventifoil, which is basically do you still see the screen? Yes. Okay. You see a ventifoil, which is an aspirated wing, which is from a Dutch company called Econowind. And in this case, it's a sort of a containerized version of it. So it can be folded into a container and be quickly put on and removed from the ship. On the right, you see the top right, you see the Flettner rotor, which is nothing else than a very large rotating cylinder. And by doing this, basically accelerate the flow on one side, and it creates a large depression and therefore a large lift. And that is an active device. Also, the ventifoil is an active device. And since so you need some energy in order to make them function. And because of this, they are able to generate a very large lift. At the bottom, you see some type of wing sails. There are many others that are currently offered in the market, but this is yeah, at the bottom left, you see the Aero wing sail from VPLP. And at the bottom right, you see another type of wing sail, which is a symmetric wing sail called, from a Spanish company called Bound for Blue. So you see there are different devices. There are many others, and mainly a different type of wing sails. They've been created for the shipping industry, but you can think, well, I will remove my presentation here. Let's see. All right. you can think that these systems have been created for the shipping industry, but they can be change in size and change also in the way they're constructed to be applied to the yacht industry. At the moment, as Donna pointed out, typical dimension is from 20 meters span to 40 meters span, depending whether it's a flat rotor or a wind sail, and that could be maybe too much for even for a large yacht. So if you think about a large yacht, it could be in the order of 80, 100 meters, but there would be a very small ships compared to the type of ships that this system has been designed for. So you can think to scale down a bit the size of these systems for the yachting industry. Also, maybe let's say the primary reason why these systems have been created for ships might be different compared to yachts. For the yachts, you can think that one possibility is, for example, to extend the sailing range of these large yachts when you sail from, for example, to Europe, from Europe to the Caribbean, or from Europe to Australia, or other different large voyages. You can, I think, fairly easily extend by 30 or 50% the range by using some sort of some type of wind assist devices. Could be a flattened rotor, or could be a ventifoil, or a wind sail. So that could be something that it could be very convenient for the owner. Also, I think it's always very nice for a yacht to be unique. I think that's something important. Aesthetics is also very important in the yachting industry. And this could make a yacht unique in the sense that it gives clear evidence that the owner is, let's say, environmentally conscious, and he's making a decision in order to reduce consumption and reduce emissions. So let's say that maybe the reason why wind assist work for the yachting industry are slightly different compared to the shipping industry, but and maybe also the financial reasoning is not so important in the yachting industry as much as in the shipping industry, and that could be one of the reasons why the system could be more quickly adopted in the yachting industry. You can also think of some systems that are not fully or not all the time installed on a yacht, because a yacht spends a lot of time in the harbor as well. But maybe you can think of something that is a sort of plug and play, so you can install it for a very large voyages and then remove it when the yachts are in port or something like this. So I think there are lots of opportunities for the yachting industry regarding wind assisted propulsion. I don't know whether, Nico, you want to add something maybe regarding the sailing capabilities of these vessels?
No, I don't think so. I think you covered it very nicely. I think maybe we can go to the questions at your discretion, Aaron.
Yeah, great. Thanks, Nico. I did want to sort of jump right back in on really on questions of envisaging this on a super yacht or something. Talk to me a bit about I guess the practical differences between what would I be getting with one of these systems that I wouldn't have on, say a system like my favorite super yachts like the Maltese Falcon or Black Pearl with I guess those are Deinemann systems.
Yeah.
What do I get with these sort of more kind of automated control and this sort of and I guess the removability of it? What are the advantages and what's this maybe the experience? How's that going to be different here? It's more pragmatic.
Yeah, well, the Maltese Falcon was a proper sailing yacht, so it's been designed with a sailing yacht hull with a keel and it's been constructed for sailing. So it has 3 very large dyno rigs, and I think the owner also probably was into sailing, so it's like the sailing experience. These are systems are more for a hybrid type of navigation. So you use wind when it's available, otherwise you compensate with the engine. So it doesn't give that sailing feeling, but it gives the opportunity to save fuel, to make your ship cleaner, in order to reduce CO2 emission and other pollutant emissions. And compared to standard sailing yachts, these systems are, as Donald pointed out, they're fully automated, so you need an extra crew. They just do everything on their own, and they're fairly simple. If you think about a flatner rotor, the only thing it does is just a spinning cylinder that basically spins faster or slower depending on the wind direction and wind speed. So it's fully automated, and yeah, as I said, it doesn't give that sailing experience, but also maybe that's something that a owner of a large motor ship, motor yacht doesn't want or is not interested into that. But it certainly gives the opportunity to save a large amount of fuel.
Yeah, and in the sense that it doesn't, full sailing experience would also entail some considerable redesign for the ship itself. Whereas if we're talking about a sort of a hybrid propulsion where, so say a modest proportion of the propulsion is given by the sails, then you don't have to, well, within some reason, you don't have to think too carefully about the impact on the sailing performance of the ship, the maneuverability of the ship, and these kinds of factors. So you have, with the relatively minor consideration, for example, many of these motor yachts have stabilizing fins for anti-roll in harbors, and these could be very well repurposed to take care of the sailing loads on the ship. Yeah, no, I think indeed the main selling point, as Giovanni said, is this, well, as I see it anyways, is this ability to extend the range of the ship. You have these quite long passages between sailing seasons that you could really take some of the, say, logistic burden off of the operator of the ship.
And it sounds like the structural requirements on the base vessel would be much more minimal compared to putting on what we think of as a full sailing rig and the forces that are at play on something like that. You had noted the kite option, which seems to be something I have seen being at least applied conceptually in the yachting sector. What are they? How do they work in terms of efficiency and I guess controls as well?
Yeah, in terms of, so the main advantage of a kite is that it's flying high over the seas, so it takes advantage of a steadier and stronger winds. So that's the main advantage of a kite. And the second advantage is that it's operated dynamically. So by making 8 figures, the kite experience much higher forces, much higher wind speeds, and therefore much higher forces. So that's the very strong selling point of a kite. The complex thing of the kite is its operability. So if you want to take advantage of this possibility, you need to operate the kite steadily, in figure of 8. And that's a challenge, from an operational perspective. So that's something that's been taken care of at the moment by these companies that are looking into kites. But they said, if you want to take full advantage of the benefits of a kite, you really need to operate it dynamically. And that's what makes it great and unique, but also what makes it so complex.
Great. Any other questions from the rest of the panel here? Super. All right, you guys. Giovanni, Nico, thank you very much.
Thank you.
Thanks.
So we'll take a lateral step in our final presentation into the world, or the world of sustainability, from propulsion technology into construction materials. Friederich, you're a boat builder of all things, and with a really compelling case study to share. The Udovrolik Design Flax 27 day sailor is a really beautiful boat underway, and performs enviably. But the real innovation is what's in our composite structure. Tell us about the more sustainable material options and how you developed or optimized them for applications in marine composites.
All right. I will share my screen. So here you can see the Flex 27, and yeah, I think it's a good example to show a bit what we do at Green Boats. So we are actually focused on natural fiber reinforced composites. So the Flex 27 is entirely made from natural fiber composites, and so it's 80% of this boat is based on natural fiber reinforced composites. But more about that. So we actually search for alternatives for glass and carbon fibers, and we find out, so like 10 years ago now, that you can replace a lot of glass fiber applications with natural fibers. So in this case, glass fiber, and so on the like in the building process, we really look, before we start building, we look on the impact of each building materials, and so we start like with the fibers. So for the flax fiber, as example, that is the material we use for the day sailor. You need just or the different way around, you need 5 times more energy for producing a glass fiber compared to the flax fiber, and 10 times as much energy for the carbon fiber. So the materials we choose are really, or we really look on the impact of the material in terms of CO2 consumption. And as example, for the core material, we use recycled cork, balsa wood, paper, honeycombs, and as well recycled cores like recycled PET. And so we end up with a material with a really low footprint, or we reduce the footprint compared to a glass fiber boat from 60 to 80%. And we get at the end of life, we get the possibility of a thermal recycling. On this picture, you can see the structure of the Flex 27, and it's entirely made, so as well as structural part you can build from natural fibers like flax. Here you can see it's an escape hatch from a performance sailboat. It's like a really lightweight, or we needed to compare with a carbon fiber hatch, and on this one we used recycled paper honeycombs, flax fibers, as well like a nano particle reinforced natural fibers, so to be able to compare in weight with the carbon fiber, and even like really big structures. This is a cover of a wind turbine. It's around 130 square meter surface, and something like that you can as well build from natural fibers and end up comparable in terms of weight and strength or stiffness to a glass fiber nacelle. That is a picture that was like in 2012. That was the first boat I've built in this material combination. It was combined. It was my masterpiece, boat building master, and that was Kolk core combined with flex fibers, and even the resin system we work with is based on plant oil. So yeah, this is a picture of the Bente 24 we built in 2016. So the first bigger boat we built from this material combination. And 2017 we built the Flex 24. Flex 27, sorry. And here, as an example, you can see the flex fiber that's just laid up and like as a dry material, and you can really like imagine how nice it is from the perspective as a builder to work with these natural materials, because they are not itchy or smelly or whatever. And that is a part from for the automotive industry, like a door panel. Here you can see the fiber wetted out, so you really get like a nice, maybe a bit technical, like a carbon fiber finish, but a lot more natural. Here, folding kiteboard. So all applications where you normally use glass fiber, you can replace with these materials. Here as well, like a geocode application for the cabin of a pickup truck, like a camping cabin. Yeah, all this is possible. So,
from Friederich, from a builder's perspective, thinking about people who are using what are conventional composite materials in boat building environments, what are some general differences that they need to look at in terms of material sort of storage, handling, the expectations? You've sort of shown us the material properties can be made to be very similar, but in order to attain those, what practices, what habits would I need to change in my shop in order to get there?
So it's actually when you have a shop, or you should be a boat builder who's doing like a pretty much high quality work. So mainly working maybe in vacuum bagging, vacuum infusion, stuff like that. If you try to do that maybe in hand layup, probably turn out that nicely, because you have like one problem is maybe that the natural fiber takes up resin. So like it's on one point it's a problem, on the other side it's like really good, because the glass fiber is just rounded with resin, and you get a lot quicker like a delamination from resin to fiber. And on the natural fiber, the resin goes into the fiber, and you got to like a really strong connection. But on the other side means if you don't stop the fiber by pressing, taking resin off, it really gets like a really big resin uptake, heavy, and not really not a nice composite anymore. So that is maybe one point that needs a bit of trying as well, and then choosing the right material. And there are actually not a lot of data for doing the construction of the composite. So we actually needed to do a lot of research, a lot of material testings to get the properties, to do the engineering of the product and doing the laminate plan. So that is something, you need to know about. So
interesting. Yeah, I'm fascinated with it. The other question I have is about vulnerabilities to water and UV abrasion. How does it hold up over time, and what are the possible vulnerabilities of that kind of composite structure?
So that is something. So you need to make sure that you have a nice process and that you wet out the fiber properly. So because if you don't do that, you probably have something that can take water somehow if you don't really wet out the fiber. So that is the only problem. Like when we do the boat in vacuum infusion, we don't have this problem. We just have like a normal water uptake from around 3%, and that is something that's given from the epoxy resin. So that is normal. The UV point, it's actually more UV resistance, and maybe change after years when you have or it's maybe comparable with a wooden boat. It will change the color probably, like you need a UV filter and the lacquer, and that does a lot or saves the material a lot. The interesting thing that the UV is not going through the fiber, so it blocks the fiber. I actually recognized that when I tried to do some UV resin systems that you hard with UV, and so I could just hard first or the top layer, and underneath nothing get hard. So
Thank you. Yeah, it's you're the only person I've talked to who's done the real research, so I'm fascinated. Thanks for your time. Any questions from the rest of the panel on the especially on the flax material?
Yeah, one question for me would really be on the commercial side: is how does it equate kind of cost wise? You know, if you can achieve mechanically the same sorts of properties, but how does it compare cost wise to traditional glass or other materials?
Right now, I think you end up like it's about the material, because the process is pretty similar. Once you set it up, everything, you probably will end up with 30% more cost in terms of material. So, but when I look on the cost of a boat, it's not much. So if the main costs are in building, and so the material, when they are like 30% more expensive, it doesn't make that much difference.
So it sounds like you need to have good builders, and then everything else will flow from that.
Yes.
Super, great, Friederich. Thank you. I think we're actually a bit past our time. Thank you all from the panel for joining us today, and we will. Simonetta will be in touch, and you guys will be available after this plays live at the Mets Connect for any questions.